Now let's talk about the difference between Bluetooth based wireless personal area network and IEEE 802.15.4 based low rate wireless personal area network. Now in case of Bluetooth, the devices which we can connect through Bluetooth are few. Typically we can connect only up to 8 devices through one coordinator, that is PAN coordinator. The data ranges from 10 meter to 100 meter in case of Bluetooth. Data rate is nearly 1 Mbps in case of Bluetooth, and power consumption in Bluetooth is higher when you compare with IEEE 802.15.4 based network. Battery life is low because the power consumption is higher, and the topology which Bluetooth supports is the star topology only. When you compare with 802.15.4, this can contain many devices because in addition to star, it can provide peer-to-peer as well as clustering topology. So many devices can be connected. Data range is nearly 10 meter because the objective of 802.15.4 based network is to conserve the power. So because of that, the data range is kept lower. Data rate is typically 20 kbps or 40 kbps or maybe 250 kbps. 20 kbps is for 868 megahertz band, 40 kbps is 915 megahertz band, and 250 kbps is for 2.4 gigahertz band. Here the power consumption is ultra low because the overall wireless sensor network is designed to deploy in those areas where power is the constraint. So in that case, the power consumption will be ultra low. So when you compare with Bluetooth, it is more power efficient. Battery lasts for years because those are deployed in those remote areas where powered devices cannot be utilized. And when you compare with the topology, Bluetooth can only support a star topology while the 802.15.4 can support peer-to-peer star as well as cluster topology. Now let's talk about the various applications of wireless sensor network. These applications can be divided into three categories. One is monitoring of the objects, second is monitoring of an area, and third is monitoring of both, that is area as well as objects. So in case of monitoring of objects, the typical examples are like wireless sensor based automatic meter reading. So here the wireless sensor network will be created in mesh format in an area, and the meter data can be transmitted to the remote server using this wireless mesh. So wireless automatic meter reading is one example. We may also utilize it for remote system monitoring or equipment fault diagnostic, condition based maintenance. So in this case you can put the sensors in the devices where the regular maintenance is required. So you can acquire data using those sensors and do some analysis to identify when the maintenance of the device is needed. We can also utilize RFID based tracking for any asset. Monitoring of an area, we can utilize wireless sensor network for topology monitoring, system visualization, stability analysis, or maybe the disaster management. In case of monitoring of both area and objects, we can have emergency response system, asset tracking, maintenance of the system, verification and tracking of crew movement, transmission line monitoring, and maybe the smart home solution. Now let's talk about the challenges. So design challenges. So first design challenge is heterogeneity. That means the devices deployed in the field may be of various types and may be needed to collaborate with each other, which is not an easy task. Distributed processing, the algorithms need to be decentralized as the processing is carried out on different nodes. So the algorithms which are running in different nodes need to have the distributed processing capability so that collaborated output is achieved. Low bandwidth communication, the data should be transferred efficiently between sensors. Large scale coordination, the sensors need to coordinate with each other to produce the required results. Utilization of sensors, in this case the sensor should be utilized in such a way to produce the maximum performance and use less energy. Real-time computation, the computation should be done quickly as new data is always being generated in the field. Reliability and latency requirements are another set of challenges. What are the operational challenges? The operational challenges are energy efficiency, limited storage and computation, resource constraints, low bandwidth and high error rate in case of wireless sensor network. Packet errors. Errors are common in the wireless sensor network due to wireless communication or noisy measurements or the node failure. So that's why multiple retries are carried out to address the errors in transmission. Scalability to a large number of sensor nodes is also another challenge. Survival of nodes in harsh environment is another operational challenge. Operations are time and space intensive, so the operations of nodes should be optimized in such a way that the desired output is achieved within the required time period. Low cost is another challenge because you deploy a lot of nodes in the environment. More the number of nodes, the overall cost of deployment will be higher. So if you keep the individual node costs lower, then we can deploy large number of nodes in the space. Fault tolerance is another challenge. Wireless channel of unlicensed spectrum is being utilized in case of wireless sensor network. Therefore, these channels are prone to interference by other radio waves which are operating in the same frequency. Since we are utilizing ISM band for the wireless data transmission, lot of other devices are also communicating using the same ISM band. So we have more problem related to radio interference. Now, how we implement the wireless sensor network? We utilize modes for wireless sensor network implementation. What are modes? Modes consist of low cost and low power computer. These modes devices monitor one or more sensors such as temperature, light, sound, position, acceleration, vibration, pressure, humidity, etc. for desired outcome. These devices connect to the outside world using radio link. Mica 2 modes are sold by Crossbow company, which was originally developed at University of California in Berkeley. It is based on Atmega 128L AVR microprocessor and runs using TinyOS as the operating system. Mica 2 mode is one of the most popular and commercially available sensors marketed by Crossbow company. Then Telios B modes, they have the USB programming capability. IEEE 802.15.4 compliant high data rate radio with integrated antenna and low power MCU is also the important components of Telios B modes. It is also equipped with extended memory and can have the optional sensor suite. Now, how we implement the wireless sensor network? We utilize various operating systems residing in wireless sensor nodes for achieving the desired objectives. The example of various operating systems used in wireless sensor nodes are TinyOS, Contiki, Mantis, BTNut, SOS, or Nano RK. Out of that, TinyOS is one of the most common operating system being utilized in the development of wireless sensor nodes. The TinyOS is event-driven programming model, which is different from our conventional multi-threaded programming. TinyOS and its programs are written in NES-C, which is very lightweight version of C. It has a small memory footprint. It is power efficient. That's why it puts microcontroller and radio to sleep as much as possible. Event-driven architecture. It is having efficient interrupts and event handling capability. But in TinyOS, the real-time operation is not guaranteed. So if you see the structure, at the base you will have hardware abstraction where the device separates the software and hardware components. In the software, we will have various functions for actuating, sensing, and communication. On top of these components, we will have the custom built application that is specific to the particular use. So all the user components will reside in this layer, and then we will have the main layer, which includes various schedulers, which makes sure that microcontroller and radio sleeps as much as possible.